Welcome to the Flux Dev Meeting. It's August 20th.
Hi everyone. Hope you enjoy your vacation, summer vacation. We are some of the Flux maintainers also take vacation, like Mateus is off for 2 weeks, which is a novelty. I'm really glad that he actually took some proper vacation, so it's only us today. Um, some news before we start. We did Flux patch release. 2 weeks ago is Flux 2.9.4. And this patch release fixes a bunch of bugs, but also comes with a CV fix. We published the CV on the Flux 2 distro. Um, so we can talk a little bit about what's this about. We still don't have a CV number for it, only a GitHub advisory number. My understanding is that the NIST, the institution that issues CV numbers, are under DDoS. Oh, I don't know. The Mythos effect, everybody is throwing at them thousands and thousands of reports for new CVs, so it will take some time. But the GitHub database is updated and most scanners use that, so it shouldn't be a problem. We went ahead without waiting for a CV ID to be assigned, and I'm guessing from going forward, this will be the case for everything. We can't wait months until we get allocated a CV ID. So this CV is about spoofing Flux events. I've been using Anthropic models and others to scan everything we can in Flux controllers and so on. And this came also as a surprise to me. This CV is not actually in a source code. It has nothing to do with source code. It's a network policy was too lax. We have this policy, network policy in the Flux official distribution. It's a network policy YAML. It's called allow webhooks. And the role of this network policy is to expose a notification controller, the webhook endpoint, inside the cluster, because you have an ingress somewhere, not in the Flux system. Maybe you have a load balancer. So then the webhooks are, you push something to GitHub and GitHub will call the cluster and say, hey, there is something new, or GitLab or whatever, right? And this is highly used into Flux because it speeds up the delivery from the moment you do a push to the moment Flux applies it. If you have this webhook in place, it's almost instant. If you don't, then you need to wait for whatever interval the Git repository or CI repository, whatever has. And our intentions from the start was to expose only the webhook. Well, that was not the case. We were exposing all of notification controller ports. And notification controller has to place two roles inside the Flux system. One is to receive events from outside, like this webhook. And another major role is to receive events from the Flux controllers, like customized controller says, hey, I have reconciled this app and it's healthy or it's unhealthy. And you can chain a Flux alert and a Flux provider, and it can open, for example, an incident in PagerDuty. And because the network policy was lax, what happens is that any pod in the cluster, no matter which namespace it is, can basically forge an event, says your app is down, and it will push it to notification controller using it has to have the format that customized controller and hand controller does. And then you'll end up in PagerDuty with a fake notification or on Slack or whatever. So the fix was very easy. We basically limited the network policy to only the port that the webhooks are. The event server, the one that all the Flux controllers are using, is on port 9090, and we close that port um, in the network policy. Basically, the network policy should only expose 90 to 92 as a port. So we fixed this, we released it. But the good news is it doesn't matter if you're not on latest Flux 2.9.4. You can at any time do this very simple patch. It's in the CVE as a workaround. You can create at Bootstrap in the customization.yaml a patch that adds the port to the network policy, so you close it completely. We are not going to backport all the Flux versions. It's very easy for everybody to add that patch there until you land on the latest Flux version, and then you can remove it. So besides DCV, this version of Flux comes with various hardenings of the Flux endpoints, Flux controllers, rate limiters, and so on. So I encourage everybody to upgrade. We did a thorough end-to-end testing of everything that we could, and there are no breaking changes in this version. So all the hardening that we did around all the controllers are fully backwards compatible. And a heads up that we are continuing, we will be continuing doing this, hardening around our Flux components. We'll probably publish new patch releases for 2.9, especially now that Helm did a patch release which contains one of our fixes. We had to, for 2.9, we had to fork again Helm, put some fixes in there so people can use Helm controller without major issues. And all our fixes have now landed in upstream in the Helm project. So we'll release next week 2.9.5, which will finally bring Flux 2.9, the latest release, back on upstream Helm. So we are very happy that the Flux Helm team managed to get all these fixes in, and we are back again on Helm upstream. So that's a good news. And with this, we are going to upgrade other components, do other types of hardening. So if you are not using any kind of automation to keep Flux up to date, I encourage you to do it now. There are various ways of doing it. If you use Bootstrap, we have a GitHub action that can open pull requests every time we do a patch release. We also have Flux Operator, which fully automates everything on your clusters. You can create a Flux instance and say Flux version 2.9.x, right? And because we do really thorough end-to-end testing, you can trust that, if we release a patch, that's fine to go everywhere in your production systems, and Flux Operator can fully automate this process for you. So you don't have to, go in there and manually bump versions, rerun Flux Bootstrap by hand, and so on. So yeah, either go with the GitHub action that does the automation if you started with Bootstrap, or if you have Flux Operator, please consider setting Flux Operator in a way that every patch gets deployed as soon as we publish it. Other things that we did, we published a blog post around Flux Mirror. We wrote a very nice blog post about it, how you can use Mirror to, pull Helm charts from HTTP repos inside your private container registry, and also mirror all the containers images that you depend on to give you better control of what gets deployed, act like a gate, and it also ensures, if GitHub Container Registry goes down, Docker goes down, Quake goes down, uh, yeah, you can still function with your own private registry. And I think that's a good approach if you have production systems that are, sensitive. Mirroring everything and owning everything is quite cheap. All the registries out there, in terms of storage, the price is very low, so you can actually afford mirroring everything without uh, raising the cost too much. And I think it's well worth investing into such a procedure. Also, we have added things like don't mirror the latest version unless the signature is older than 24 hours, 48 hours. It's up to you to set it up. This also helps, with someone took over some maintainers' GitHub account. They publish a malware in the container registry. They will sign it if someone takes over, for example, I don't know, one of the Flux core maintainers accounts that have power to do Docker push. Um, if you do Docker push from a local machine, the signature will not match anyway. But if you take over the account in GitHub, what we've seen with the latest attacks is, um, the hackers are not doing a push from their machine. They will modify the uh, GitHub workflows. So the malware will get signed, we'll have salsa, we'll have all the things in place because they are modifying the workflow, they are pushing the workflow, triggering it, and they are distributing the malware as the original maintainers intended to distribute their project. So by just checking, a signature that yes, this image was signed by this GitHub entity proves to be not enough, right? You need a cooldown period, um, especially on big projects that are open source projects that are everywhere. All the security teams are scanning them continuously. So if you have this, back off of cooldown of 24 hours, couple of days before you get the latest version, there are 99 to 99% chances that if a malware was published, a security company has found it, GitHub took it down, or Docker took it down, and this kind of buffer of a couple of days will protect you against shipping bad things in your production systems. Yeah, and I don't think there is a way of it goes against the fact that we should patch as fast as possible, right? There are like these two things are competing with each other. Like, for example, in Flux, we published a CV, you should, as fast as possible, roll out that patch. On the other hand, what will stop an attacker from publishing if he takes over a account of a maintainer? They could go into GitHub UI. They could register a new CV there, publish the CV, publish their malware as the fix for the CV to trigger the depend upload renovate whatever to fast track the fix. So we have this conflict, right? It's like, should you patch right away or should you actually wait even if there is a CV? No one can decide for you. You need to think it through. You need to analyze. For example, with the Flux CV, you don't even need to update anything. You can just patch it. So I think it's important to still have humans in the loop when it comes to doing all these sorts of upgrades and deciding on your own, is this CV worth it? Fixing right now, or should we put in place cooldown mechanism and wait a couple of days because we are not going to get hacked overnight by that CV. But the decision is between these two, it's not universal, right? If there is a, I don't know, a major CV in the ingress controller or the proxy that you are exposing your whole production system on the internet, right? There is, I don't know, HA proxy has a major CV and everybody can hack from there. Um, Maybe you should choose to patch immediately and risk malware than not patch it and risk being like, it's so damn complicated, right? And it depends a lot of your exposure, how is your infrastructure set up and so on. But with Flux, it's quite obvious. Flux, the controllers that are running as cluster running, that should never be exposed anywhere. So having like a cool off for those couple of days should be fine. With other things, is not that simple decision to make. Lee, you wanted to say something?
Yeah. It's like there's a you can have like minimum age, kind of implemented in your automated pipelines for updates that you are not necessarily monitoring, right? And then when the internet says, yo, there's something really wrong with a particular piece of software, this is a great way to augment, collaborating with the robots, right? Where it's like, okay, the min age is kind of importing the thing, maybe sending you a pull request automatically, after, 3 days, 1 week. But then you realize, oh, there's some critical Go vulnerability that, allows something to manufacture a packet that can affect controller runtime. Oh, okay, well, everyone's going to be updating their controllers. Like, let's, figure out how to roll these out and get that into dev as soon as possible. Um, so I see this as definitely a more responsible way to not care about your updates until you need to, you know. Um,
You definitely need to consider, though, having a CVE score and CVSS score are not enough to evaluate. You need a list of known exploited vulnerabilities that's updated from somewhere. So you can, like for our example, we have an organization that publishes a bulletin about known exploited vulnerabilities. And when one of those pops up, you'd probably better install the update. Uh, so long as you're not accidentally exploiting the vulnerability yourself. You guys know I have a third-party Flux controller that sends notifications to the notification controller, right? It
Yeah,
lives
yeah,
it lives in the Flux system namespace, so it's actually fine.
yeah. Yeah, if you have a controller that lives outside, the solution is here you have to create another network policy on top to explicitly allow only that controller to access it, right? So what we did now, by default, we are closing everything from outside Flux system namespace, but how network policies work, of course, you can create another one on top and say only from this pod in this namespace, I'm exposing the event receiver, right? There's a beauty of network policies that they can be layered on top. But of course, you need to understand, like if you, let's say you have TOF controller or some other controller that sends events and you are going to automatically update to Flux, it will no longer work. You are not going to see those events anymore, right? So you need some kind of way of figuring that out. Maybe you are not going to see anything on Slack anymore, and someone should ask what's going on. They should go to the Flux uh, CV report and see why is that the case, right?
I never even thought of this as a security boundary, but it is. Who knows if
So
notifications are load bearing? There are many configurations where they can trigger downstream activities.
yeah, and like how I see this vulnerability is also about has also exposure to DDoS. Let's say you have this pod that's running somewhere in the cluster, and it sends hundreds of requests per second to the notification controller. Notification controller can take millions of requests per second. It's a Go, stateless web server. It can deal with massive load, but it will definitely DDoS your Slack. Your Slack will ban the cluster IP, right? Because it will see like millions of requests
Oh,
coming to
I
the
was
Slack
just
API.
thinking I'm not going to be able to see my notifications anymore because there will be so much noise in the channel.
It
That's
will
not the
not
worst
happen.
of it.
You will
Huh.
not even see them. What will actually happen is everything will get dropped by the firewall, the rate limiter of Slack, of PagerDuty. All of them have this, right? So, and you're going to get your egress IP completely banned. Good luck removing that from the whatever slack.com, pagerduty.com, and so on. You'll not be able to do it, right? So that can have like serious implications on your uh, operations and observability part, because all of a sudden that cluster will be completely banned. And how are you going to get another egress IP? In some cases, depending on where you're running, you have zero control over that. One gets assigned to you, and that's it, right? You need to recreate the cluster and hope to get another IP. Or there are so many complications coming from this. So it's not like you'll not be able to DDoS Flux itself, because, as I said, the Go HTTP server that runs inside notification controller can take a beating. You are going to DDoS all your alerting providers, and they have very hard limits in place and so on. So it can result in really, really bad things, right? And from our perspective, like when we built Flux, we said the network policies are the boundary. We are sealing the Flux system, right? And that's how we protect ourselves from, bad actors running in the cluster, because in some cases, tenants are not your teammates. Not everybody runs clusters where all the apps that are deployed on the clusters are, let's say, produced by someone in your organization. There are people using Flux out there where the tenants are isolated to Flux multi-tenancy and there is no trust on them. They run untrusted workloads by vendors, by whatever, right? So we really need to assume that the network policies are a requirement and they are the only way to protect the Flux controllers and Flux system. Um, I was debating if that should we roll our own, PKI at Flux Bootstrap and do MTLS between the controllers. That's another way to seal it. Let's say you could disable network policy at that point because you need the MTLS stuff. But doing that, then we are definitely banning any third-party component for ever talking to Flux, because the PKI,
Not
the
necessarily.
CA will be in the Flux system, right? Like if
Yeah,
you have a
'cause
controller here,
it would be part of the onboarding process for a third-party extension to, yeah, have the cluster administrator use the CA to mint them a client certificate, similar
and they
to
have to, but they
admin.
have to have the code in there. Like no third-party Flux controller has code in there where it can talk to source controller, notification controller using MTLS. There is none
Yeah, it would
because
need to be
Flux never did it.
sidecar proxy or something.
Sidecar proxy, change
Yeah.
the controller, copy the certificates there
Yeah, it would
because
be
you
like
can't
very
reference.
similar to like an admission webhook or something like that in the Kubernetes control plane. Complicated.
It complicates the stuff a
Yeah, it
lot,
would be
right?
super complicated. There's a reason why we've avoided it when network policy is, sufficient for most people, but I think yeah, like defense in depth, there's definitely things that we could build. Um It makes sense for Kubernetes because people deploy Kubernetes in untrusted network environments. I think probably there are a lot of users who are actually deploying Flux in untrusted network environments with no network policy, which is not a good configuration. But yeah, I mean, nothing is stopping people from modifying Flux and adding their own MTLS sidecars if they want, just wrap Flux in your own service mesh. But
Yeah, but this is also a problem with the chicken and egg situation, right? Usually, if you do GitOps, Flux is the first thing that lands on the cluster, and Flux sets up the service mesh. So let's say you have some kind of kube job that does kubectl minus n Flux system delete pods, right? Because you need to delete all the pods after the service mesh is there. So it will get a sidecar or whatever. But at Bootstrap, you are still exposed, right? So that's, in my opinion, not a solution. It's not a good solution because it does not cover the most sensitive part of what's happening at cluster Bootstrap, right? Another solution so we are now, hopefully in 2.10, we are going to integrate with SPIFFE and Spire, right? And we are going to be able to do MTLS with external systems from source control and so on. We could use the
that's not a bad idea. I like that.
those certificates inside
Yeah.
to talk between the cluster
If
between
Spiffy is available and all the controllers are used
yeah.
already, might as well just speak to the
But
controller with Spiffy. But
it's yeah, right. But it's also, we also have the chicken and egg problem because we need the Spire operator to run in the cluster, right? And who is
yeah,
going to deploy that? It's
it
Flux who
would
deploys it.
yeah, probably like you'd have um
So we are back on
we
the service mesh
we
stuff.
could we could actually write a config map lock or a secret lock inside the Flux system namespace. The feature could be designed to bootstrap itself canonically. Um, we implement a feature gate. If the feature gate is enabled, Flux is looking for Spiffy Spire. So I haven't found it yet. Writes, okay, this is the first time I tried to do it. It's got a timeout, of like 2 days or something to see the first Spiffy setup, and then if not, it starts spewing errors everywhere.
Yeah, but you'll still run on without MTLS the first time, right? My
Exactly.
other
Yeah.
yeah, my other proposal, I wrote the draft RFC, but it's far from being ready to be reviewed by anyone. Um, my other idea was creating PKI with the uh, Flux CLI or the operator or whatever machinery deploys it, in the same way that Linkerd and others are doing the initial bootstrap.
Yeah. Yeah.
So
When you
let's say the CLI will create a CA bundle, will create short-term certs that are there in the Flux system namespace, and it switches the future flag on all the controllers. If you opt, this is totally opt-in, it's not going to be the default. Um, and it switches the future flags for the Flux controllers to say, oh, if I see an HTTP URL in the whatever artifact status, right? If I have the future flag, I will just do HTTPS using this key and DCA. Hard code it to a name, Flux, Trust, Flux, whatever. So at Bootstrap, they will talk over TLS, not MTLS, and source controller, notification controller will talk to the Kubernetes API every time they receive a request over TLS and see if the service account that calls them, the token that's sent, is minted and approved by the Kubernetes API for the audience Flux system.
Interesting. Yeah, just
Um,
use the Kubernetes. Just rely on Kubernetes as a spiffy implementation.
yeah,
Uh,
yeah. And
there's
then
yeah.
wait a second. So okay, we bootstrap this initial TLS, but I don't want this to be there going forward, because then you need to run bootstrap the CLI every month or every
To
week
do
or
the
every
CA cert rotation.
to do a cert rotation and so on. And my idea was to create certs exactly like cert manager does it. And the trust manager will create the bundle and cert manager will create the certs. So have the CLI or Flux operator create the bundle and the certs identical to how cert manager does it, and use the cert manager manager field for server-side apply. We apply it once there, we bootstrap Flux, it uses this
Okay, yeah.
certs that we provision.
Yeah.
Of course, it uses the Kubernetes authorization. Like I said, that's unchanged. But then the first thing Flux can do from your repo is deploy cert manager, trust
Deploy
manager,
cert manager,
with
configure
the
that.
bundle definition, with the client, with the certificate there as definition in the repo. After a couple of minutes, cert manager takes over, rotates first time the certs, and then you control through the cert manager custom resources. Okay, I want to rotate every hour, every minute, every whatever. It's up to you. It's in your full control. And then when you run the CLI again or operator again, the operator will see, okay, this has actually been taken over. We will add an annotation, or we can actually rely on the creation timestamp that Kubernetes embeds on the secret, and we see, oh, okay, it was created here, last update was here, so this is definitely rotated by cert manager. I am not touching it anymore. We can also add the if not exist annotation label that it's implemented everywhere in Flux. So there are many ways of how Flux can say, I'm only creating this at Bootstrap because there is no infrastructure in place to actually do the things. But we need to nail
If you were
how.
to, yeah, just implement standard support for MTLS client configuration, that it would be possible to write Bootstrap repos using Cert Manager and Spire, where Cert Manager and Spire and their adjacent tooling provide you the ability to do that, like kind of bottom turtle, like TLS initialization.
Yeah. And you'll see in the RFC, I'm not even proposing MTLS because MTLS is not needed. Only TLS is needed because the actual authorization or source control notification controller are through the SSR, through Kubernetes API, where source control as the Kubernetes API is the service account trusted. Does it have the claim that I need to issue responses to it, right? And that's available in every single cluster. We already do this in Flux Web UI, right? When someone logs in, we ask the cluster if that
Yeah,
identity is trusted and everything.
this is using the JOT through like normal basic
Yeah,
auth. Um and then just with TLS. So it's a authorization technique instead of it's a layer 7 authorization instead of MTLS.
yeah. Now, if you
But then you
don't trust the network,
rotate the
right?
certificate.
If you don't trust the network where the nodes are running, this is TLS between the two of them. So the communication is encrypted. Right? We eliminate that problem by just doing TLS. But now the problem
Yeah,
becomes,
for man in the
how can
middle.
I trust? How can I trust this entity? right? And how you can trust these entities asking Kubernetes. Is the job that actually created by a customized controller? And Kubernetes can definitely say that because that's built into Kubernetes. And every cluster out there can do this for years now, like many, many years. It's not a new feature. So that's something to consider. It's not complicated to implement it once we analyze what Cell Manager and Trust Manager are doing, so we can issue these certificates in a way that they can take
The
over them, and it's quite
the
easy.
TOS hosting is actually kind of optional. Um, like that's really just like solving secrecy on the wire.
Yeah.
Um, yeah, so your token doesn't get stolen, I guess,
Yes.
because it's a base
Uh,
token. Yeah.
yeah. So the first version of the RFC, when I wrote it, had no TLS at all. And then Matteo said, it's important. We can't ship this. No go, because that token represents the customized controller identity, which can
Yeah.
connect to remote clusters, to the other things. So if you sniff it from the node, and we can assume that, like you said, right? Maybe
Yeah.
you don't trust the network where you're running, and it's a good assumption, right? Not everybody runs on AWS or Google where the VPC is encrypted. If you run there, like it's kind of useless. But if you run on, I don't know, on some data center, on-prem, on the
Yeah,
hardware
or a network
rented
from
by,
McDonald's, yeah. That I don't
yeah,
know.
who knows? Who knows
Yeah.
where you're running?
Some retail
So
store, yeah, an airplane, whatever. Yeah.
yeah. So uh, then I realized, oh, damn, yeah, because these tokens are very powerful, right? They actually represent customized controller and Helm controller, which are cluster admins, which can connect to other clusters, which have their own tokens that are super powerful, right? So we don't want anyone to be able to sniff them. But we still don't need all the complications of MTLS and so on. We can just have TLS. We send the token encrypted. So even if something on the node does, how is it called? The sniffing tool, TCP dump, right? If it does a TCP dump on the node, it will not see the token because we send it over TLS. And then source control asks the Kubernetes API, is this actually coming from customized controller? And that's over TLS as well, right? Because the API connection is TLS. So we are,
It can even be a specific audience that's like for the purpose that it's supposed to be.
yes. Yeah. So how I wrote the RFC, the audience is one audience, which is the trust boundary of the Flux system namespace. So you have the audience, and whatever JOT it's issued for that audience has to be in the namespace, in the trusted namespace, in our case, Flux system, or whatever the namespace is where you deploy Flux at Bootstrap. Um, so we are, by default, we are not trusting anyone outside of the namespace. So this is like um, a representation of the network policies, right? Because the network policies are doing this, are sealing the Flux system namespace. And this is also sealing the Flux system namespace where network policies are not enough because, you don't trust the CNI. Everybody can be in that CNI and look at things and call Flux
It
controllers.
depends in depth.
Yeah.
Some people don't even have a network policy implementing CNI.
Yes. And if you don't have that, like Flux is naked.
Yeah.
Like you can send events, you can pull sources, you can trigger reconciliation through the whatever the endpoint. Sure, you shouldn't keep any secrets in plain text in sources, but you know how it is. We can't force people into doing that. So the risk is there, and the DDoS
Somebody
risk
was doing
more.
in esoteric here where they weren't running the Flux controllers on a Kubernetes node, they would not be able to use this feature. Or they would need to, yeah, they could use the Kubernetes clusters PKI to create some like fraudulent service account JOTs or something that actually were signed by the API server CA.
But if you're not running the Flux controllers, how are they going to apply anything on the cluster?
It wouldn't be a problem. Yeah.
So
Wait,
I don't think
how are they
like
gonna?
yeah, if customized controller is not running in Kubernetes, it will not be able to do a reconcile
Why not?
because it needs to talk to the API through the and present its identity, right? If it can't present the identity to source controller to verify it, how would anything else work? Like,
Yeah, exactly. That's what I'm getting at. Is like if you have this authorization layer that's dependent on Kubernetes SAs, that they would need to disable this feature in order to use it, or you would have to create SA
yes.
certificates that sort of fake the JOT being signed or something like that. Um, well, actually no, because yeah, like you can give customized controller a certificate with RBAC to request the JOTs. So it might work.
Yeah, I think it will work as long
Even if
as
you're
all
not,
the
yeah, even if
controls.
you're not on the node, that's sort of a benefit of it is, yeah, Kubernetes is basically like a Spire server based off of the certificate. Like
Yep.
based off, like if you can give the a client certificate to customize controller that API server believes is good and can be assigned to RBAC permissions, which is required for Flux to work, then yeah, even if you're not on the Kubernetes node, you could use this feature to get JOTs that are temporary
Oh
for the
yeah, we definitely don't rely on the node identity at all. The JOT and source control will never verify node identity. Of course,
Yeah, I was thinking in my head that this would require a kubelet, but it doesn't because we are asking for a very specific jot. We're not using the jot that's placed ambiently in the pod.
no.
Yeah, we're doing
We
it
we are
via our back
we
and
doing give me a
explicit.
JOT
Yeah,
for
the jot
Flux
doesn't even land on
system.
disk. It's
Yeah.
only in memory inside the controller.
Yeah. Yeah,
Yeah,
so customized controller will present itself to
yeah.
Kubernetes API and say,
However, it
I need
however it
you
does
to
probably
issue
using
me
its
a
ambient
JOT.
SA.
Yeah.
Yeah, yeah,
Ambient and say, please give me a JOT minted for Flux system.
yeah.
Takes that, then he sends it to source controller. Source controller asks the Kubernetes API, is this JOT valid? It is. Does it has the audience that I'm supposed to approve? It does. Cache it for 60 seconds, right? So we don't DDoS the Kubernetes uh, identity, like the CSSR, the one that does the verification, and we can cache it for 59 seconds. Anyway, we can the JOT also contains the expiry, right? So we can actually look at that, but those are hours and so on. To just not DDoS the Kubernetes API, I think in the RSC I said like we are going to cache it for a very uh, like
Short period of time. Yeah.
yeah, up to 1 minute. And the reason is that, when the cluster bootstraps, there will be like hundreds of calls from customized controller and hand controller to source controller to get new artifacts. The artifacts are not there. Retries, right? And I don't want for source controller to every second to have hundreds of EasyJot. Okay, EasyJot, the same one, right? So we can cache it for under a minute. Then you it expires the first time someone calls it their identity, we are going to cache it, right? So we don't
If
DDoS the Kubernetes API in this way.
if
And
somebody is has a basically constant throughput of messages that require these jots, and we cache for 1 minute, then the controller, each controller that wants to communicate at that max throughput would be asking the Kubernetes API server for 1440 tokens a day. It's reasonable.
yeah. I mean, I we are not doing anything out of ordinary. All the service meshes are doing this already. All the sidecars are doing this.
At
Uh,
caching interval?
with JOTs, like exactly this
Yeah.
operation that I'm talking about. Linkerd
Yeah.
is doing it, Istio is doing it, all of them are doing it. And from what I've seen, I think I looked at Istio, it does this uh, up to 1 minute caching
Okay.
at the
And I
sidecar
guess it'll
level.
be tunable, but that's a good default.
Sure, we can allow people to increase it. Um, yeah, but
It feels
it
like the
can't
kind of
be
thing that
more
somebody
than
might
the
want to tune with Flux.
yeah, but it can't be more than the we are going to no matter what you said there, we are going to enforce the expiry
Yes.
because you can't set the cache 2 hours, but Kubernetes API issues the token for 1 hour, right? Because then we are going to cache things that are expired, right? And
And
we
we
don't
can
want to
we
wait.
can ask for we can control the expiry as well in our request, right?
Uh, no,
Or
I
no?
think it's a hard limit somewhere, if I
Okay,
remember correctly.
cool.
Um, but anyway, the limits are quite high, so it's not you don't want to cache this stuff for days. Makes no sense. Um,
So we could set a range then or
yeah,
something.
you can set it to everything, but if you go over the expiry, we are going to use the expiry minus a couple of seconds. This is already what we do for workload identity everywhere.
Mhm.
How Flux because we have caching of workload identity. Otherwise, no one could use Flux with DCR. Right?
Mhm.
DCR will like ban you instantly if you have 1,000 OCI repos, and we are going to mint tokens 1,000 times every minute, right? If you have 1 minute reconciliation. And how's that implemented? We have a cache in source controller. So we are reusing the whole infrastructure we already have. This is not that much extra code. The cache is there, the limits are there, and based on the JOT expiry, the whole code is already there because we are doing this kind of operations with all the external services where we support workload identity. Uh, We are just going to apply this quite similar procedure for inter-controller communication authorization. But yes, we need this TLS complication. So I really want to spend more time into building like a proof of concept, seeing how Cell Manager and Trust Manager, how they generate all these objects, pick a good, uh, an acceptable, strong
If
TLS
uh if
version
Flux
and
Bootstrap can initialize the PKI, that's really simple. It's like one file of Go. And that can be a 1 year cert or something, or it would be fine if it was nothing else needs to talk to Flux that way. Maybe the
well,
webhook server.
third party controllers.
Yeah, but then it's like you can just give them a client cert too. Or oh no, it's yeah, they don't need a client cert. Like yeah, they just need the CA.
The CA, right?
Or
Exactly.
they can do it insecurely from the Flux system namespace. It's still like you still get secrecy even if you don't trust the cert. So yeah, okay. Anyway, And then
Yeah,
of course
but my
bootstrapping
my
to cert
idea
manager.
is so my idea is like if we can transparently offload all this after Bootstrap to Cell Manager,
Yeah.
then when you have a third party controller, you are going to create a Cell Manager certificate that points to that CA.
Hmm. Yeah, what I'm
And
getting at is we don't need to build the feature in a way that's any more complicated than just doing the initial PKI, and then we can document. Um, we just
yeah, I
document
mean,
the example as like,
we,
hey, you should use Cert Manager. You could use this feature
yeah, yeah. So, but my, what I'm trying to say
or
is that,
Google Store or whatever. Yeah.
what I'm trying to say is that before going any further with this RFC and ask for reviews, I want to actually see that you can bootstrap this infra and then you can offload it to Cell Manager without no downtime, no nothing, right? That means
I
the
mean,
source
like a
controller
GKE
has to have,
user would probably even skip Cert Manager for this and just like
sure,
make a certificate object, right?
or the, I don't know, AWS has also
Yeah.
a thing, right?
Uh, it's
Um,
it's like kind of like in all the Kubernetes as a service stuff, it's normal to have an Acme thing that can just mint you certs in
yeah.
Kubernetes.
And you'll mean for the short name and the full name, right? The
Mhm.
short name will be source controller, that's it, right? But if you want to allow all these third party controllers to live outside, then you also have to, the cert that source controller loads also have to have the full qualified name. The cert has to have that,
Yeah.
right? The source controller
Sorry,
dot
I
flux
have
cd dot service dot, everything.
other little questions and I'm gonna have to drop in 2 minutes for an internal meeting, but can we get serving certs from Spire?
I
Can
think
we
so, yeah.
a serving TLS cert?
I think through cell manager we can. I don't think directly, but
Mm,
cell manager can use
can use its
can be
identity.
the yeah, can be
Okay.
the provisioner. Or if I
Yeah.
understood it correctly, I mean Mateus definitely knows way better than me.
Because I
This we
think Spire
can.
is similar to a CNI where it's like you could expect that it even is on the cluster before Flux, right? Like it's
Not to, yes, but with the socket, and that means you need to run Flux on the node like the CNI daemon, which we don't want, and that's why we have to use the new stuff that Mateus contributed, where you can run as a pod and you don't have to have host network to mount the socket, right? Because it's that new thing, the
mm.
workload API that gives you certs directly. You don't have to talk to the socket anymore. Is that controller
That's
that does
for
all the
issuing
magic?
estimates. That's not for getting your own identity from Spire. That will work
Right,
without
that's it.
talking to the socket. That's what we would need.
Yeah, yeah, yeah. Yeah,
But
so maybe I don't know. It is definitely if we can make Bootstrap work with the CLI and then Set Manager take over, I'm guessing you can then replace Set Manager with many other technologies that are able to issue this stuff, being
yeah,
Spiffy, Spire, whatever,
I
being
think the
the cloud native.
interoperability with normal TLS stuff. I feel like the MTLS stuff will not be hard to bolt on either for people who want to do that. Could also just make sense if somebody already has a service mesh on the cluster.
Oh
But
yeah, yeah, yeah.
But yeah, I think the Spiffy Jot stuff using the Kube API like that holds up nicely for the Flux application in the same way that it's, works for the service meshes.
Yeah.
And obviously everything we already tried with Flux Operator, UI and MCP.
Yeah, and we like
I like it.
I also did
I
stress
feel good about it.
tests for the assertions in web UI, and it scales really well. So I'm not concerned about source control asking the API, is
Hmm.
this actually customized control, right? It's it's is not because Kubernetes API already has all this in the memory. It will never hit etcd to do this authorization to say yes,
Before I
right?
hang up, I should mention that somebody asked for an interesting feature in Flux Mirror that we might have to say no to, but I asked them to write a GitHub issue about it because I
Yeah,
think
I've seen it. Yeah,
yeah, good to log the user intent. Um,
yeah.
But
Building charts and extracting images with again. No,
I
yeah,
think
no.
maybe having this in documentation or something, or maybe this would be a scenario where shelling out to Helm could make sense. You know, like this is FlexMirror is intended, primarily in a CI use case. If you want to, do some, like maybe we can use Helm template as an API or something, inside of FlexMirror and do it declaratively. It does feel like it would be a really common use case. They also wrote on Slack that like it's kind of a heuristic use case where you're sort of trusting the contents of the chart. So maybe this is something more where it's like the very first time that you ingest a chart, maybe you use FlexMirror on your laptop and it helps you parse a Helm template and then spits out a config, and the config is declarative or something. But it's a
Yeah.
usability issue in the same way that like handling the secrets, Bootstrap is. Um, where it's like you've got to figure out where the images are coming from.
So
So
how I generated all these mirror configs is with AI.
yeah.
I told AI, look at this chart, figuring out all the images in there. And the surprise is when I told that for the Envoy gateway that I want to use in my home lab, Table discovered them. The Envoy images are not in the Helm chart anywhere, are hard coded in the source code
Mm-hmm.
of the Envoy gateway in Go.
Mm.
It figured out, it extracted from there, and it wrote the mirror config for me.
Hmm.
So just having the chart is not enough in some cases because,
Yeah, because if there's an operator that, wants to create a Kubernetes pod with a different thing and it
yeah,
uses some config from some structs in Go or Rust or something, yeah.
yeah,
Got
yeah.
it.
So even building the Helm chart may not be enough. So that's why I'm saying like it's so fragile to do it
Yeah, it,
with a bash script that Helm template grep for image. Yeah, it will work in 80% of the cases, but
it
in
would be nice
20%
as
of the
well if
cases,
like
it's
when you're copying an OCI chart, if you could follow like refers. I think that would be maybe more in FlexMirror's kind of purview is if the chart OCI chart it like refers to the images that it depends on, then maybe that could be reasonable to do recursively.
refers don't work cross repo, so that's impossible. A
Yeah.
referrer works in the same repo, and you can't store the chart and all the images in the same repo because then you have server overlap.
Mm,
Yeah,
yeah.
that was an old idea of mine. I discussed it back then with the people from the OCI team. I say like, no, 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 you got it very wrong. Referrers are
Is there like a
for
CNAB like annotations or something? There like where you can just like put some other repos or it feels
oh
like there's
yeah,
a
like
way for Helm to say I depend on these
the
images.
yeah the artifact hub, the project that publishes charts.
Yeah.
They tell people use this artifact hub dot images annotation, put a pipe there, and put images on a new line, and then you
Maybe
parse this
support that.
annotation. You on
Yeah.
the new lines, and that's how you get the image. Is
Anyway, we have an issue for it.
yeah.
This is really fun
Okay.
meeting. I'm gonna drop now. I have
Right.
to, yeah. Okay.
You know, Kingdom, we are done. You can stop the recording. Have a nice day. Bye.